Find an approximation of the area between the curve y equals sine x and the x-axis from x equals 0 to x equals pi using 12 centered rectangles. Now let's think about what this looks like. So sine x looks like this from 0 to pi. The width of the interval is pi, and we're using 12 rectangles. So each rectangle must have a width of pi by 12. Let's think about that first rectangle. Now, obviously, this is much further than pi by 12, but I want it to be visible. So pi by 12 is here. My first rectangle will have a height the same as the center of that region. So this will be my first rectangle just here. Now clearly this is at pi by 24. The next rectangle over would be here. And since they all have a width of pi by 12, the distance from here to the center there must be pi by 12. So I'm starting to build up where I want to actually calculate. So I'm going to want to calculate at sine. Now the first one I want to do is pi by 24. The next one I want to do is at pi by 24 plus pi by 12. And then the next one after that would be pi by 24 plus pi by 12 times 2. And then the next one would be times 3 and then times 4 and so on. So what I'm going to do in here is put a plus y minus 1 pi by 12. So that is going to give us each of the heights as we move across the region. Then all we're going to need to do to get the actual areas is multiply by the width, which is pi by 12. So that should work. And if we use the same sort of method I used at the end of the last example to save us doing all that working, so I'm going to do pi by 12 which is the width times, and now I want the various heights. So I am going to use a summation. Now I'm using sine here, so I'm just making sure I'm in radians, and I'm going to use y as my running number. So I'm going to go from y equals y equals 1 to 12 because I've got 12 rectangles, and then in here I'll put in sine, and we'll do pi divided by 24 plus y minus 1 times pi over 12 so just checking the number of open and closed brackets here. I think I might need a closed bracket just there to get that to work. And then let's execute and see what it comes to. So I get 2.0057, say. I wonder what the exact is. Now we're going to be coming onto this soon. So that would be the integral from 0 to pi of sine x dx, and that is exactly 2.